Using Desmos, we can demonstrate the relationship between a function and its reciprocal. I'm going to try another linear function here, f at x equals x plus 3. Of course, we can see here now that the x-intercept is at -3, no big surprise, and it's increasing over its entire domain. According to what we said before, its reciprocal, which I'm going to call g at x, and that's just simply 1 divided by f at x. Notice that where the x-intercept occurred for the linear function, we now have a vertical asymptote for the reciprocal of it. The green one was increasing over its entire domain. Its reciprocal is decreasing over its entire domain, except, of course, where it can't cross the vertical asymptote here. When the original function f at x the y values are positive, the y values on its reciprocal are going to be positive as well, but as the y values get large here on the reciprocal, the y values approach 0. Same thing that happens over here as the y values get more negative as you move to the left. The y values on the reciprocal are also negative, but the larger negative values would end up, when you do 1 over a large negative value, you get a very, very small negative value. If we try to find the reciprocal of a quadratic function, let's say f at x, and for the purposes of making this example a little bit easier, I'm going to say we'll put it in factored form, so like x plus 1 and the other thing will be x minus 2. Of course, we know that the zeros are at -1 and 2, as you can see on the graph. So what's going to happen when we do the reciprocal of this is at -1 and 2, we're going to get vertical asymptotes again because you can't divide by 0. I'm going to write this a little bit differently. G at x equals 1 divided by, and then x plus 1 and x minus 2. So as you can see here, at -1, the 0 of the quadratic, you get a vertical asymptote. Also at 2, the other 0, you get a vertical asymptote. Same relationship between, decreasing the opposite effect on the reciprocal. It's increasing on this interval. Notice here the parabola is decreasing until you get down to the vertex. On its reciprocal, it's increasing. This point right here, the turning point on the reciprocal, is simply the reciprocal of whatever the y-coordinate of the vertex is. So if I just click on this right here, you can see the vertex for the parabola is 0.5, -2.25. So if you actually do the reciprocal of -2.5, you get that point right there. which I believe is negative 4/9. This would be negative 9 over 4. Once again, when y is positive on the original, the reciprocal is going to be positive as well. Where y is negative on the reciprocal, it's going to be negative.